In this lecture, let's begin taking the correct steps to add the knockback mechanic and functionality to our game. We've got a lot to cover in this one. Let's dive in. Let's go ahead and create a modular C# script in our combat folder called Knockback. Now think about how we're going to make this class. We need to make it in a modular way so that it works both for our enemies and our player alike. So let's go ahead and get it attached to our player game object. I'm just going to go ahead and click my player game object and add my knockback class. While we're doing that, let's also add it to our enemy prefab. So prefabs folder, enemy. I'm just going to scroll down and add the component knockback to it. So with that added to our enemy and our player controller and that in mind, let's open up our knockback class and start writing some logic. Let's go ahead and grab a few references to what we know we're going to need to get this working. I think the most obvious one is going to be our rigid body. So let's go ahead and grab that. Private rigid body 2D, we'll just call it rigid body as we've done before, and let's go ahead and grab that in awake. So rigid body equals get component rigid body 2D. I think another one that makes sense that we can set up in our knockback class is how long we want our objects to get knocked back. So let's create that as a serialized field in case we want to edit it in the inspector. So let's call it private float, and I'm just going to call it knockback time. Then I'll initialize it to something like 0.2f. It feels like we're using that number a lot. Now let's have a think about what else we're going to need. We're going to need the direction, so we're going to need a vector 3, and then we're going to also need some sort of knockback force, what I'm going to call knockback thrust. So let's go ahead and set those up as well. I'm going to need a private vector 3. We'll just call it hit direction. And like I said, we're also going to need a private float called knockback thrust for the amount of force we'd like to add to our rigid body. Now this knockback class is added to both our player and the enemy, so we're going to need some sort of public function to get these set up properly. So let's create a public void that I'm just going to call get knocked back. And that's going to take in a couple parameters to properly get these references. So let's go ahead and take in a vector 3 called the hit direction and another float called knockback thrust. And we can use this public method from other classes to properly get the direction and the thrust. For example, the thrust from the bullet might be a little bit different, and then later on we're going to implement things like a grenade, and maybe the thrust from the enemy to the player is not as strong as the other way around. With those parameters set up, let's go ahead and assign them properly. So all we need to do is just say hit direction equals hit direction, and knockback thrust equals knockback thrust. And the reason we're doing this and we're not applying the rigid body add force sort of physics right away is we need to use an event-based system. We need some sort of way that other classes can communicate with when we're getting knocked back. For example, later on, we're going to initialize a little bit of a flash sort of white mechanic to when our enemies take damage. And we also need to make sure that both of our enemies and our player can't move when they're getting knocked back. So we need a couple different events up top. So let's go ahead and implement the system namespace. And right up at the tippy top, let's create a couple of those events. We're going to need a public action that I'm going to call on knockback start and I'll just duplicate that and call it on knockback end. And you'll notice we actually did not use the static keyword. That's because we don't want this action to be attached to the class directly. We need it to be attached to the instance of this class, in other words, this specific model behavior. So let's create another function to actually apply some of those rigid body physics. Let's just call it private void y knockback force. And in here, we can actually apply those physics. So we're going to need the direction, specifically the difference. So let's do a little bit of vector 3 math. Let's just call it difference, and then we'll take the transform.position of the game object that this class is attached to, and we'll minus the hit direction. That'll give us the proper angle to get knocked back from, but we're using these parentheses because we need to normalize it just as we did before, I believe, with our bullet logic. Let's make sure we times it by our knockback thrust. Now this last part might be a little bit unnecessary, but I also like to times it by the rigid body.mass, maybe to give us a little bit more control in the inspector should we need it. Then all we need to do is go into our rigid body, add force, and then just like we did with jumping in the player controller, we can just take the difference to get our specific direction, and then just use that force mode 2D dot impulse to get that nice little jump back in the proper direction. The next thing we'd like to do is implement a coroutine to make sure that we're only getting knocked back for the specific amount of time that we declared up top. So let's create a private IE enumerator that I'm just going to call knock routine. In here, we can just yield, return, new, wait for seconds, and pass through that knockback time that we set as a serialized field up top. Cool, so we've got the skeleton of the basics of getting started to get knocked back and the ending of getting knocked back, but let's actually fire those events where necessary to get that logic working properly. So right here, after we declare these references, let's just go ahead and start our knockback event. So on knockback start question mark to make sure that we're not getting any null reference exceptions, dot invoke. And then we can subscribe our apply knockback force to it. So let's go ahead and do that. So right here below awake, let's go ahead and create an on enable and an on disable if I can spell correctly. There we go. Let's start with the knockback start. So on knockback start, we'd like to subscribe our apply knockback force. And on knockback end, we'd like to basically stop getting knocked back. So we'll go ahead and set that up in a second. Stop getting knocked back. Perfect. And then I'm just going to copy and paste these two lines down here, switch these to a minus instead of a plus just to make sure it's getting subscribed and unsubscribed to correctly. And let's go ahead and create this function as well. Right below our knock routine, let's go ahead and create a private void that we can just call stop knock routine. And all we need to do in here is just stop our rigid body velocity. So we've done this a couple times before. Nothing much to talk about. Let's just go ahead and set our rigid body velocity to vector2.0. I'm going to highlight this with Control C, scroll on up, highlight all of this, stop getting knocked back, press Control D, that'll highlight both at the same time, copy paste it with Control V, and with a semicolon at the end, we're set to go. I think the last thing I'm missing is at the very end of our knock routine, we just want to start a knockback end and invoke that event as well. And I think I'm just missing right here when we basically start to apply that knockback force, we just need to start that coroutine. So knock routine, and we'll do it just like that. Okay, wow, that was a mouthful. Let's do a little bit of testing before we move forward. So I'm going to go ahead and in my get knocked back method, I'm just going to go ahead and add a debug.log and we'll just call it knocked back, just to make sure everything is at least rigged up correctly. And where should we actually test this? We're going to need it for both our enemy when it gets hit by a bullet and as well as our player. But let's just start with our enemies as well. Our player doesn't have anything like a health component yet. So let's just start where I would do it normally if I was building something like this. Let's go ahead and open up our bullet class. And right here on our on trigger enter, when our enemy is taking damage, let's actually do the same for knockback. So we can actually follow this syntax pretty closely. I'm just going to go ahead and say knockback. Call it knockback with a lowercase k. Then we'll just say other.gameObject.getComponent knockback. And then we'll do the exact same thing. So knockback question mark. And then I think we called it something like get knocked back. Yeah, perfect. Right here, if we hover on over, we need a vector3 for the position. And then we also need a float for the knockback thrust. So let's go ahead and create that actually as a serialized field up top, since our bullet probably wants a different knockback thrust than say something like our enemy. So let's create a serialized field, private float, we'll call it knockback rust, just like this, and we'll set it to something like 20. That might be a bit exaggerated, but let's make sure that we can see it. I'll copy that since we're about to use it down below. I'll paste that in, and then right before our knockback thrust, we also need that vector3 position. Now this part's a little bit tricky because we don't really have a great way at the moment to get the direction that the bullet is actually moving. Now we're going to implement that a little bit later on. So as a placeholder at the moment, and something that's going to be really close to the proper direction is just the player itself. Well, we actually have an instance for our player, so we can just go into the player controller class, type instance.transform.position to get the position of our player. Now that might not be exactly perfect, but it's going to be pretty close, so I'll use that as a temporary solution at the moment. Nice, let's go ahead and give that a save and try it out back in Unity. I'm going to open up my console, re-enable my environment to give us some enemies to play with, and we'll see where we're at so far. This isn't going to quite work correctly at the moment, but let's just go ahead and fire some bullets. Okay, perfect. Our debug.log is working as intended, but we're not getting that actual knockback effect. We'll go ahead and have a think at why that might be, and I'll give you a bit of a hint. think about how we're moving both our enemy and our player controller. Well, in that movement class, we're moving the rigid body, so we need some sort of way to toggle the ability to move off and on when we're getting knocked back. So let's go ahead and open up our movement class and add some modifications there. Now, I'm going to implement about half of this as a challenge, but let me get you this skeleton set up somewhat correctly and pointed off in the right direction. In our movement class, we need some sort of way to check if we're getting knocked back or not. Well, because of the event-based system that we've already rigged up in our knockback class, we have a great skeleton that we can just plug into manually from our movement class. So we're going to need some sort of way to subscribe to those two actions in our knockback class. But let's create a private bool called canMove, and we can just start that and initialize that to true at the beginning. That's just fine. And all we need now is some way in our movement class to subscribe to those two events of when we're getting knocked back and when we're finishing getting knocked back to properly make sure that we're only moving when we're not getting knocked back and this bool is set to true. Well, let's get you pointed in the right direction. You're going to need to subscribe to something in onEnable, and you're going to need to unsubscribe to something in onDisable. Let's create a couple void functions called canMoveTrue and private void canMoveFalse. With that skeleton in place, this lecture's challenge is going to be writing some additional logic in our movement class and make it so the game object the class is attached to can't move while it's being knocked back. Use our onKnockbackStart and onKnockbackEnd events to properly do so. Now, this is going to take a couple different steps, so put on your game dev thinking cap and how you'd go about implementing that with this skeleton that we already have in place. Give it an honest effort, pause the video, and I'll see you back here in a few moments. All right, welcome back. Let's finish off this skeleton. So canMoveTrue, nothing much there. I'm just going to set canMove equal to true. And then in canMoveFalse, I'm going to do the exact opposite and set canMove to false. In our onEnable function, let's go ahead and plug in and subscribe to some of those events in our knockback class. So first, it looks like we're going to need a reference to knockback, so private knockback. We'll just call it knockback. And let's go ahead and grab that just with equals get component knockback. There we go. So underscore knockback, and then we can subscribe to onKnockbackStart. And what function are we trying to subscribe? We'd like to make it so we can't move, so canMoveFalse, as well as knockback.onKnockbackEnd. And we'd like to make sure that canMove is true. I'll just go ahead and copy paste and change these to minus signs. And then I'm going to scroll down, and in my move function, we just need to do a little check to see if we're able to move. If we cannot move with that exclamation point, then I would just like to return. Hey, you know what? I think we're set to go. Let's go try it out back in Unity. We've got both our console log saying we're being knocked back, and you can actually see when a bullet fires. It's a bit exaggerated, but you can see that each individual enemy is getting knocked back. But we still have a lot more to add for both physical and visual feedback to the user. Let's keep the pace high and keep moving forward. When you're ready to move on, I'll see you on the next one. Steps to introduce a flash mechanic so that when our enemies get hit with our bullet, they have that nice little flash mechanic when they get hit. Let's make sure we set this up in a modular way so that we can also eventually add it to the player. So I'm going to go inside of my scripts and combat folder, and I'm going to create a new C# script that I'll just call Flash. And before we go directly into this C# script, let me actually give you a little bit of guidance on how we're going to set this up. So both in our enemies and in our player directly, we have some different sprite renderers that we can work with. So if you take a look at our character sprite, for example, we have this nice sprite renderer. And if we can actually just toggle and change this material briefly while it's getting knocked back to kind of a nice little flash, well, that'll achieve that look for us visually quite nicely. So in our assets and materials folder, let's organize and create those materials. Now I'm going to organize this just a tad. So I'm going to create a folder called physics materials. And with that physics materials folder created, we can just throw this no friction physics material inside of here. And then I'm going to create another folder called textures. Now they're not necessarily textures like 3D models, but I think it's nice to differentiate the two. And in here, the way that I've actually found that we can do this is we can go into create material, and let's just call this white flash. And then we can change the shader to shader, I believe it's GUI, and then text shader, which might sound a little bit silly, but if you actually drag this white flash material into the material property field, then it actually gives us this night flash effect that we're looking for. Then we just have to set this up and toggle it through code. But one thing that I'm going to do to make sure that I can toggle back to this default sprite lit material is I'm going to click this, find out where it's actually located in my universal render pipeline runtime and materials, and I'm actually just going to Control-C to copy this material, and then I'm just going to paste it back in my materials folder, just so I have a nice place to easily find it when needed. So back in my textures folder, if I hit Control-V, that'll give us a nice way to easily drag it into my soon-to-be serialized fields in my Flash class. Now you don't need to do this, but just watch along for just a moment. If I drag in my enemy prefab and actually open up the visuals of the sprite renderer, you can see that I have both an outline sprite renderer and a fill sprite renderer. And the reason I have it set up like this is I'd like to be able to change the colors of my slimes appropriately. Sooner than later, we're going to change it so that different colors will spawn out of different colored pipes and things like that. So I do actually need to make a mental note that we have both this outline, which I don't want to change the color of this. I think it looks a little bit silly if the eyes change colors and things like that. So we do need to make a mental note that we both have the outline, which is this thing right here. It's both the outline and the eyes. And I don't really want to change the colors of that. I'd like to leave it just a nice white. So I set it up this way to have two separate sprite renders, and we need to make a mental note of that. I can just go ahead and delete this enemy prefab entirely, and let's head into our Flash class and start building that out. So scripts, combat, and let's open up our Flash class. Now, as we chatted about before, the way that I'd like to do this is setting up a coroutine to just flash for a set amount of time while we're being knocked back. So let's get us a couple different serialized fields for those materials as well. So I've got a serialized field for a private material. And we'll just call this the default material, and that's going to be that sprite unlit material that we copy and pasted over. Let's get another one. I'll just duplicate it, and we'll call this one the white flash material. So white flash material. Let's have another serialized field for a float for the amount of time that we're actually flashing. I think the way that I phrased it before is that we can flash while we're being knocked back, but that would look a little bit silly if it was flashed the entire time while being knocked back. So I'm going to actually set it up as its own serialized float. And we'll just call that flash time. I just want it to flash for just a split second. So something like 0.1 seconds ought to do the trick. And we also need to get the sprite renderers that we'd like to flash. Now in the case of our player, we just have the one sprite renderer, but in the case of our enemies, we actually have two. So we need to actually get both sprite renderers. Now there's probably a couple different ways that we could get those two sprite renderers, but I'm just going to go ahead and cache that in an array with both of those sprite renderers inside. So I'll call that sprite renderers with an S at the end. And then in awake, we can just set sprite renderers equal to get components in children, since we'll be attaching this to the parent game object, and it will have both of those sprite renderers as children. Sprite renderer, and not get component, get components with an S, and that way it'll go ahead and set both of those sprite renderers inside of this sprite renderers array. Nice, let's go ahead and create a public method of some sort that we can call this flash method from other classes, just like we did with Knockback. And I'll just call that start flash. And in here, we'll start a coroutine. Well, what is that coroutine? Let's go ahead and create a private IE enumerator that we can call flash routine. And in here, we just want to set each sprite renderer to flash for just a second. So I'm going to use a for each statement, go into my sprite renderers array. We'll just call it SR for sprite renderer. And instead of using variable, we can just set it directly as sprite renderer. And in here, we just need to change each individual sprite renderer material to be that white flash material. After that's done, let's go ahead and wait for that split second serialized field that we set up top. So yield return new. Wait 4 seconds. Perfect. And we'll just pass through the flash time that we set above. After that, we just need to set the default material back. So I'll go ahead and create my own separate method for that. And we'll just call it private void set default material. And here we can just do the exact same thing. So I'll copy and paste this logic here. And instead of setting our sprite materials to the white flash material, we just want to set it back to the default material. Right after we wait that flash time, we want to call that method set default material. Nice. And this is going to do the trick almost. We just need to rig up where to call start flash. But before we do that, let's go ahead and start that coroutine of our flash routine. And where should we call start flash? Well, let's actually just rig up the enemy, just like we did with our knockback class. Our player isn't quite set up to function properly yet. And where did we do that before? In our bullet class. Now, this is starting to, in my opinion, get a little bit messy. So, for example, if we just added some additional functionality here and we followed this exact same logic, well, it's going to actually kind of get a little bit repetitive, and this isn't really the best way to go about doing it. So this is setting us up nicely in a way that pretty soon we can refactor some of this code using things like interfaces. So we'll get to that shortly, but for now, let's just make sure our Flash class is working. So let's go ahead and set this up the exact same way. So get component from our other.game object, and we'll just check to see if it has that Flash component. So Flash question mark dot, and then what did we call it? Something Flash, so start Flash, perfect. We'll refactor this in a lecture or two using interfaces, but for now, let's just focus on our Flash class directly. Let's head back into Unity and see if this is working. We don't need to worry about setting up our player yet, so let's just worry about our enemy prefab at the moment. With that open, we'll open up my materials folder, textures, and right here, we'll go ahead and add that Flash class. And in those serialized fields, we'll drag in our default material, which is just this basic sprite-lit default, and the white Flash material will add this white Flash. Nice, let's go ahead and see what that looks like. And I'll give you a hint. It's not going to be quite there yet. But the logic should be close. Perfect. So when we get hit, we still have this debug.log. We can get that cleaned up. We're getting knocked back, and you can see that little bit of a white flash. But it's not flashing entirely the way that I would like it. I'd like it the way that we showed with the player before, where the entire model actually flashes white. Well, why is that? Well, that's because we have this outline and this fill. If you actually notice, even if we change this fill sprite render to the white flash material, it still actually stays pink. And that's because this color property needs to actually be white. And you might be asking yourself, well, why don't we just change the color property to just white and not worry about the material? Now, that would work for the enemy, but it wouldn't actually work for the player. So we're trying to set this up in the most modular way possible that we can use the same class for a plethora of different game objects. So I'll go ahead and Control Z that, make sure my prefab doesn't get messed up, and we'll move forward to this lecture's challenge. And that's going to be inside of our Flash routine, set up some additional logic to make sure our sprite renderer's color also changes to white. Now, don't worry about changing it back to pink yet. We'll handle that together shortly in a future lecture. So for now, this specific lecture's challenge is going to be just making sure the entire model flashes to white. It'll stay white because it's not actually going to toggle back to pink yet. Don't worry about that yet. Give it an honest effort, pause the video, and we'll go through that together in a moment. All right, welcome back. Inside of Flash routine, I'm just going to make sure that each individual sprite renderer dot color is set to white. And the way that we can do that is actually just calling color dot white. Let's try that out back in Unity. Let's see if we can hit an enemy or two. Perfect. It's got completely flashed white, and it kind of turns into a ghostly-like figure. You know, that actually looks kind of cool, but it's not the exact effect we're looking for. In the next lecture, let's set up a color changer class to make sure that not only our color gets changed back to pink, but that each individual slime can eventually have its own set color depending on the color of the pipe that it spawns from. When you're ready to move forward to the next lecture, I'll see you there. In this lecture, let's introduce a new color changer class that can not only wrap up and finish our knockback logic, but it'll also introduce our enemies on our pipes to each having their own unique color to add some variety to our scene. Let's get that set up. Let's go ahead and create that color changer class that we can use. So in our scripts and enemy folder, I think is a good place to create it. Let's create a new C# script, and I'm going to call it color changer. And this is going to allow us to do a couple things for both our pipe and our enemy alike. So let's go into both our enemy and our pipe prefabs. We'll do them one at a time. And we can actually set our enemy sprite renderers of our fill all the way just to a default white because we'll be setting it manually by random inside of our color changer class. So on our enemy, let's add our color changer script that we just created, as well as on our pipe. Let's go into our pipe fill as well, and then we'll also change this color to just be a nice default white as we'll be changing that in our script directly. On our pipe, let's also add our color changer class. Let's hit save, and then I'm actually going to go into this console log. I don't think we need this anymore, and I'm going to just go ahead and delete that directly. I'll hit Control P, and we'll open up our color changer class, and we'll start introducing some new functionality here. So we only really need to worry about the fill of our sprite renderer inside of our enemy and our pipe directly. We don't really need to worry about the outline. So I'm going to create a private sprite render serialized field that I'm going to call fill sprite render, and we'll make sure we assign that in the inspector. And above that, I'm going to create a few different colors that I can assign in the inspector. So I'm going to create a serialized field, and I'm going to have an array of colors that we can actually just change the colors directly in the inspector. So I'm going to say color array, and I'll call it colors with an S at the end to make sure it's plural. For now, let's create a public void set color method that we can call from other classes. It'll just take in a color, and we can change our fill sprite renderer color to the color that we pass through as a parameter. Now I'm setting this up as public because back in our Flash class, so instead of actually just changing our sprite renderer color here directly, let's actually do it in our color changer class, and I'll show you why in just a second. So first, let's make sure we get that color changer class directly here. We'll go ahead and call it underscore color changer, and I'm just going to grab that in awake. So underscore color changer, get component, color changer. Down here, let's just say if there's a color changer, because there might not necessarily always be if we're using this on our player eventually. So I'm going to say if color changer, and then to keep it all in one line, I'm just going to say color changer dot set color dot white. Now you could of course break this into a couple different lines, but I think since it's just one little line of logic, I'm just going to keep it all nice and clean with one line. And at the end of our coroutine, we need a way to set it back. So we need some sort of way to set a default or starting color in our color changer class directly. So heading back into our color changer class at the very top, I'm going to create a public color that I'll call default color. But let's make sure we have a public get and a private set to make sure that we're not modifying it from outside of this class. And right at the very top, let's create another public void set default color. That'll also take in a color as a parameter, and then we can set our default color to this color that we passed through, as well as change the color directly. So set color, and then we'll just pass through this color as well. So we've got this nice little waterfall of logic to make sure that everything is getting changed properly along the way. So we haven't used this yet. Where could we put this? I think it makes sense to actually put directly in our enemy, and then we can pass down the color from our pipe to our enemy when it's instantiated. So right here, we can actually create some sort of public initialization method that we can call in our pipe. So right below start, let's create a public void init function, which will also be handy if we eventually object pool our enemies. And in here, we just need to also pass down a color. Let's make sure we grab the private color changer class directly here in enemy. We'll just go ahead and call it color changer, and we'll grab that in awake. So color changer equals get component color changer. Here in init, we can go into our color changer class and just set the default color to this color right here. And where are we going to call init? Well, we can actually call init directly in our pipe class. Well, in our pipe, we also want to go ahead and get our color changer here as well. So let's go ahead and do that. That way we can properly pass down this color. So underscore color changer, and we'll go ahead and grab that in awake as well. Get component color changer. Lots of color changers in this lecture. I like it. After we grab our enemy, let's go into our enemy, say init, and then just grab our color changer dot default color of our pipe. Well, we haven't actually set a color to our pipe yet now, have we? Except I want to make sure our pipe gets set to a random color every single time an enemy spawns. So we need to set up some sort of set random color method in our color changer. So right below set color, let's create another public function that we can call set random color. This time around, we can just set a random color based on the colors that we define in our array. So I'll say int random num, and then we'll say random dot range 0 to colors dot length, because you can set as many colors as you'd like. And then we'll set our default color up top to be equal to colors decided by this random num that we just defined here. Next, we just want to say fill sprite renderer dot color equals the default color that we just decided from our random colors. So if we call this method every single time in our pipe class that an enemy spawns, so we can say color changer dot set random color, we have this nice flow of logic from top to bottom where we set the color of our pipe and it gets passed on into our enemy, and then we can set that default color appropriately so that it can flash in between using our flash class. With all of that set up, even when we do things like a death particle effect and a death splatter, we can pass down that color property logic into those additional effects. Now, this is one of those moments where that was quite a mouthful of logic. I think we need to do some testing back in Unity, but I'll admit it feels like I forgot something. Let's see how we did. So with our pipe prefab still selected, we actually have this color changer class and we now have this array of colors. So I'm going to create 3 different colors. You can create as many as you'd like. And I kind of like something a little bit more pastel-y. So I'm going to create somewhat of a blue pastel. And then we need to make sure we drag our alpha transparency all the way up. Never understood why it by default gets set to 0. I've always thought that was a little bit weird. So I'm going to create a blue, maybe sort of a pinkish thing, kind of like we had before. And let's also do a green of some kind. I think that'll look nice. Let's make sure we drag the alpha transparency up on all 3. I'm going to drag my fill sprite renderer into this property here. Copy component, head on over to my enemy prefab, and on my color changer, I'm going to right click and paste component value somewhere right here. And then we just need to drag in manually this new fill sprite renderer for our enemy. Now, like I said, feels like we forgot something. Let's hit play and see how we did. Hey, alrighty, we've got our enemies being properly set up with each individual random color, and I think the pipes are changing a color every single time something is spawned. Looking great. Looks like all we forgot is just making sure that after the flash routine that our color is set back properly to our enemy. Well, I must admit, that actually worked out really quite well, and I intentionally did leave it this way because that introduces us to this lecture's challenge. With our color changer class put into place, finish off our knockback logic, making it so that our enemies flash back to their original starting color as intended. I think we have everything in place for you to be able to do that and finish off our flash logic inside of our flash class. Pause the video, give it an honest effort, see if you can rig up everything together in 1 or 2 lines of code, and I'll see you back here in a few moments. All right, welcome back. I'm going to open back up my flash class, and I think somewhere in here when we're setting our default material back, we just need to follow this same sort of logic. So I'm going to copy this and we'll see what we need to change here. And then we'll change each individual sprite renderer not back to white, but we need to change it back to our default material inside of our color changer. So we can just say color changer.default color. Let's head back into Unity and see if it all came together. Moment of truth. Let's go ahead and flash. Yes, back and forth. It looks like they're not only being knocked back, but they're actually getting a nice little flash color all the way back to the original color. So it looks like they're not only flashing back to that white, they're getting knocked back, they're getting destroyed, and we've got our entire game loop working perfectly so far. I think we can continue on this path and add a little bit more visual feedback with both. I think we need a little bullet projectile sort of instantiation particle effect, a death effect. Let's keep moving forward and get some of that set up in the next lecture. In this lecture, let's get some fun death effects going with a little bit of a death splatter. From when our enemy dies and is destroyed, it'll leave this nice little splatter on our tile map. Let's get that set up. Now, the way that we do this is with a sprite mask. So if you follow me along here, we're going to need a couple different prefabs. First, let's create an empty splatter prefab that we can just call splatter. And in here, we'll attach a sprite renderer. We'll head into our sprites folder. I think it's an enemy. And we'll drag in this splatter sprite. And inside here, where it says mask interaction, we want to change that to visible only inside where there's a mask. So that'll get rid of it, but you can still see the outline. And then what we can do is we can create a mask that we're going to put on each individual one of our tiles on the tile map. And here's how we do that. Let's create another empty game object, and I'm going to call this tile sprite mask 32 by 32. Now, the reason I'm calling it 32 by 32 is all of these tiles are 32 by 32 pixels. A little bit later on, we'll add a few more different tile masks as well for things like platforms. So we just want to differentiate it, just letting us know that this is the 32 by 32 kind of base default one. Inside here, we can add a sprite mask. And then we need to assign a specific sprite to this sprite mask. I'm just going to choose any of our base tiles that are 32 by 32. So all of these would actually work because they're all the exact same shape, which is what's important. So I'll just choose this one because it kind of looks the most vanilla basic sort of one. And there you go. You can already see it coming to life. We can actually drag this tile sprite mask over here, and then we can just move our splatter around, and that's actually the only place that it's going to appear. Now here's the really cool part is we need to actually get this tile mask prefab on each individual tile of our tile map. And here's how we do that. Let's go ahead and make these two things prefabs. I'm going to drag this splatter prefab into my prefabs folder, but then I'm actually just going to go into my tile map folder, into my tiles folder, and then in here I'll just create another folder called tile mask prefabs, I think makes sense. And then I'm going to drag that in directly to here. So we can go ahead and get rid of those two prefabs. And if we open up our rule tile, you actually see this little option where you can put a game object. And in here, we can attach that prefab to that game object field, and where each individual tile is, it will basically put that prefab on top of it. So I'm going to click this little lock button, open up my tile prefabs folder, and then I'm just going to drag this in to my 4 or 5 different tiles inside of my rule tile. So 1, 2, 3, 4, 5, great, looks like they're all filled up. I'm going to go back into my prefabs folder where we put our little splatter. And then to make sure that it appears on top, I'm going to add a sorting layer specifically. I'm going to click the plus icon and then specifically add a VFX sorting layer that I'm going to make sure is always rendered on top of my default layer. So with that created, let's go back into my prefabs folder and make sure that my splatter prefab has the sorting layer of VFX. So now if I actually drag my splatter back into my screen, you can see every single tile now has that tile mask prefab on top of it that has that sprite mask essentially. So now all we have to do is basically instantiate this sort of splatter prefab wherever our slimes die. Pretty cool, right? Let's go ahead and set that up. So I'll just go ahead and Control Z that out. And I'm going to put this in my health class because I think that's a good place to start. And we can go ahead and instantiate that whenever our slime dies. So right at the very tippy top, I'm going to go ahead and create a serialized field or a private game object. And I'll call it my splatter prefab. And right here, when it takes enough damage and we get destroyed, we just like to instantiate that. I'm going to do it in my own other little private method. We'll call it private void spawn death splatter prefab. And we'd like to grab that game object. So we'll call it new splatter prefab. And let's instantiate it. So instantiate, we want to spawn that splatter prefab right at the position where we die. So transform.position, and we'll just use transform.rotation. If you wanted to get real fancy, you could probably randomize the rotation or something like that. We'll leave it at that for now. I think that's just fine. Let's see what that looks like. So right before we destroy it, let's just call spawn death splatter prefab. Let's head back into Unity and see if that works. I'm going to navigate over to our enemy prefab. I think it might have already actually been selected and I just deselected it. And let's just go ahead and attach our splatter prefab to this splatter prefab field. Let's hit play and give it a shot. All right, 1, 2, 3. I got to kill one. Yes. All right. Perfect. We've got it properly being instantiated and we get that nice, cool death splatter effect. But I think you can see the next logical step, which is going to be making the death splatter the color that our appropriate slime is that's being destroyed, which will introduce us to this lecture's challenge. Change the color of the splatter prefab to be the same color as the enemy that was killed. You should have everything you need. Give it an honest effort, pause the video, and I'll see you back here in a few moments. All right, welcome back. So here on Spawn Death Splatter Prefab, let's go through that together. I'm going to need the sprite renderer of my splatter prefab, so we'll just call that my Death Splatter Sprite Renderer to make it nice and clear on what's going on. We'll go into my new splatter prefab. We'll get the component of my sprite renderer. Next, I'm going to need the color changer of the enemy that dies. So color changer, we'll just call that color changer, and then we'll get the component that we know is also attached to this health game object. So color changer. Next, let's grab the specific current color. Now, you might be asking yourself, why am I doing this all one at a time? Well, this is the law of Demeter, which is basically we only want to do one piece of logic at a time in each line. So instead of just getting the color and saying get component, color changer dot default color, Well, you could do that, but I'm trying to be nice and clean. So let's get the color next, which is the current color. And we'll go into the color changer and grab the default color. And last but not least, let's change the sprite render dot color equal to that current color that we just grabbed. Let's head back into Unity and see what it looks like. Alrighty, 1, 2, 3. Oh no, I destroyed that one in the very middle. Got to destroy it next to a tile prefab. Ah, perfect. We got that little green splatter, the blue splatter. Perfect. We are in business. Let's keep going and add some death particle effects next. I'll see you in the next lecture. Flavor to when our slimes die and add some additional particle effects on death. Let's hop into our assets and prefabs folder and let's just organize this a tad. So I'm going to right click, create a new folder, and I'll call it enemies. And I'm going to go ahead and drag in my pipe, my splatter, and my enemy prefab. We'll drag it in there. And for my bullet for now, let's just create a player folder. We'll throw some more things in there shortly. And one more. So create folder and let's create a VFX folder for this lecture here. Inside of our hierarchy, let's go ahead and create that particle system. So right click, create, I believe it's in effects and particle system. Let's go ahead and call this one the base death VFX. Now we're going to create this in a way where we're going to branch off and use a couple death VFX prefab variants for both of our enemy and our player. So let's start with a base one that we can use as our base prefab and branch off from it for our variants. The first thing I like to do is just change this to not the silly little square white thing coming out to make sure we're spawning the correct particle. So in our assets folder, materials, I'll put this in textures. Let's go create a new material. And I'm going to call this the border particle. Now later on, we might use some effects called the no border particle, so I've organized it as such. And in here, we can change the shader to particles and standard unlit. That way it'll give us this nice albedo maps little section here that if we click that and we search for particle, I believe, we can actually see those two sprites that I was talking about. So I've got a particle no border sprite and a particle border sprite that you can probably just barely see. You could use either or, but for this one, I'm actually going to use the border so you can barely see this nice little border on our sprite. I'll go ahead and click that and I'm going to change this from opaque to fade. And if we hover back into our hierarchy, click our base death VFX and scroll down to the very bottom in our render field, right here is where we can drag in this new material. So if we take our border particle and drag it into this material section, and voila, we have our new material spawning in our particle system. Awesome. Let's go get the basics of this set up. So in our order and layer and our sorting layer, I'm going to change this to VFX to make sure that it always spawns on top. And I'm just going to change this to 1 to make sure that it actually spawns above even things like our death splatter that we set up previously. And let's just start from top to bottom. I don't pretend to be some sort of particle system wizard, so I'm just going to do the absolute bare minimum basics. I just want a really basic splatter effect. So I want the duration to be very quickly, something like 0.1, and we don't want it to loop. We want our start lifetime to have a little bit of variation, so I'm going to have a random between two constants, and I'm just going to have each particle be somewhere in between 0.3 to 0.5 seconds. I think a start speed of around 5 is probably good, and I just want one little quick burst at the very beginning. I'm going to scroll down, open up my emission tab, hit the little plus icon to add a single burst, and then change my count to something like 8. And I click play. Perfect. Currently, it's spawning going a cone, just going up. So if I find our shape property and I change this field from cone to sphere, I think we actually are going to be about there. Yep, that looks about right to me. My sphere, shrink down the radius a little bit since I want all my particles to be a little bit tighter towards the center. So down here, there's a little shape tool. I'm going to click this and then just drag that in just a little bit just to give us a little bit of a tighter radius. So if I click restart one more time, yeah, I think that looks about right to me. Now, currently, I'm feeling a bit silly. Haha. I'm going to add just a little bit more of a count to mine, maybe something like 12. Oh, okay, maybe I went a little bit too overboard. Let's find a nice middle ground at something like 10. Perfect. And if I scroll down here, one of them is size over lifetime. I just kind of want them to shrink over time. I'm going to open this up by clicking this little field here and just flip it to shrink over time instead of being completely flat. That way it's going to look something like this. Yeah, that's looking pretty good. And you can imagine all we need to do is change the color once again. So I'm not going to have you do this in a challenge or anything like that, but if you were to change this to something like pink through code, we've got a nice little clean splatter of whatever color that we decide. So I'm going to change that start color back to white, And I'm going to go ahead and make this base death VFX a prefab. So I'll open up my prefabs folder, and in my VFX folder, I'll just drag that in. Now, if I delete that from the hierarchy, we can actually make a prefab variant. So if you right-click this, go to Create, and find Prefab Variant. If you click this, it's going to not only copy it, but it's going to become a variant of this prefab. Let's rename this to not the base death VFX. Let's call it the enemy death VFX. And we know it's a prefab from a couple of these different icons. For example, this one here has this nice little clean square icon. If you click this one here, you can see that it looks a little bit different, telling us, hey, this is a variant. So if you were to click one more and say create prefab variant and say the player death VFX, even though we're not going to rig that up for quite some time, now you can actually make changes to both of these separately, but if you were to actually make changes to the base, it's going to apply those changes to both of our variants, which is very handy. So let's go rig up spawning this enemy death VFX inside of our health class. Let's open that back up in VS Code. Right below here, let's do something very similar. So private void spawn death VFX. And let's go create a serialized field up top for that game object of the particle system that we just created. So I'll duplicate this line, and I will call mine the death VFX. And let's go back to this method and create our logic. And to be honest, it's pretty similar, so we can copy a lot of what we have above. So I'll create a new instantiated game object that I'll call death VFX, and we'll instantiate it just like we did before. So we'll spawn in our death VFX at our transform.position with a rotation that is the same of this health class. Now, how do we grab that particle system? Now, to be honest with you, I have to look this one up just about every time, but I'm going to grab the particle system.main module, and I'll just call it PS for particle system. We can go into our death VFX and get the component for our particle system. Not only that, but we want to grab .main. With that set up, we can actually change the particle system color. So we need to actually grab the color just like we did here. Now, I'm going to go ahead and copy and paste it. You could potentially cache these references up top in Awake or something along these lines. I think doing it twice is not too much of an egregious sin, so I don't feel too guilty about it here. So we'll just leave it there for now, and then we will go into the PS, the particle system, grab the start color, which is the field that we want to modify, and we want to change it to the current color. Very nice. Now with this logic created, you could of course just plop this method in here. There's nothing really too wrong with that. That would be just fine. But this is right around the point that I'd like to start implementing the observer pattern. So let's set up an action that we can subscribe to everything that we need. So using system right up top, let's create a public action that we'll just call onDeath. And we'll go ahead and subscribe to those two functions that we have created down below. So we need an onEnable and an onDisable. Right here, we'll subscribe to those two functions. So onDeath plus equal, and what did we call them? Spawn something. Spawn death splatter prefab. Great. I'll just copy that, and then we'll rename this one to spawn death VFX. Great. We'll go ahead and copy and paste these two lines and onDisable, and then holding Alt, I'll just click right here, and then I can change them both at the same time to a minus sign. Now, instead of calling spawn death splatter prefab directly, we can just go ahead and invoke the onDeath event. Nice. Let's go ahead and see what that looks like in Unity. Now there's one thing I am realizing I'm just forgetting. So on our base death VFX, you're going to have a lot of those spawning in the scene. So to clean up our hierarchy, you can actually go in and somewhere along here, I think in the stop action, you can change that from none to destroy. So as soon as this particle system finishes its life cycle, it'll actually just automatically destroy itself in the hierarchy. I think that's a fine way to set it up for now. Let's go into our prefabs, enemies, our enemy prefab, and assign it that death VFX as appropriate. So enemy death VFX, I will just drag that into my health death VFX field. Let's go ahead and hit play and see what this looks like. So perfect. As soon as it dies, we not only have the death splatter, we also have that particle system being instantiated. Super cool. I'm starting to love this already. This is getting to the point very quickly, where I could probably just go around and kill enemies for quite some time. Now we have a bit of an issue, albeit relatively small, so let's see if I can actually make it happen. So right there. So I paused it, and let's take a look at what happened. I actually destroyed the pink slime after the blue slime, but the blue slime stayed on top of this pink slime as far as which one was being rendered on top of the other. I don't really like that. As far as visual feedback is concerned, it can be a bit wonky to actually see, and if you were to destroy a green slime right here and not see the green splatter, well, that's going to play kind of a bit of a trick on our eyes, and that's going to kind of feel a little bit icky. So let's handle that on the next lecture. When you're ready to move forward, I'll see you there. In this lecture, let's refactor some of our code to implement a death handler class to not only make things a bit more modular, but clean up our code architecture. So with our health class open, one thing that always gets me really excited is code architecture. Once we start to get more to those intermediate levels of programming, we get to start asking ourselves some code architecture fun questions. Things like, does our spawn death splatter prefab and VFX effect really belong in our health class? Well, I would argue no. We should probably keep health, and we should keep these sorts of effects decoupled from our health class. So let's go ahead and do that and create a death handler class that can work for both of our enemies and eventually our player as well. So inside of our combat folder here, I'm just going to go ahead and create that directly inside of VS Code. So I'm going to right click and create a new file, and I'm going to call it the death splatter handler.cs to make sure that it knows it's a C# file. I'm going to use my Unity code snippets and just start typing mono and then hit complete. Give us this nice mono behavior class as a starting point. And this is also going to introduce us to something new and fun where we can actually start to learn how to pass through logic through our action events. So let's go ahead and set that up. We're going to keep this public action on death directly in our health class, but we're going to add the static keyword to attach it to the class itself. But very importantly, to make sure that we can pass through data properly, we can actually pass through this health class directly inside of our event. But let's go rip some of these things out and put it in our death splatter handler. Now we want to keep the splatter prefab serialized field and death VFX prefab. I'm going to keep it in my health class to make sure that things like different enemies or a player can each use their individual splatter prefabs if we have them, or their different VFX prefabs if we have them. But I am going to take this on enable and on disable. I'm going to control X. I'm going to head over to my death splatter handler, and I'm just going to paste this down here. We can also do the same for both of these methods entirely. So both my spawn death splatter prefab and my spawn death VFX, I'm going to do the same. I'm going to cut that out and I'm going to paste it over in my death splatter handler. But now heading back over into our health class, we need to actually pass through this specific instance of this health class because we're passing through this health class through our action event. So to do that, we can just say this, and that way that'll pass through this specific instance of this health class. But we need to also make sure that we can access these two prefabs in our death splatter handler. So the way that we can do that is just using some short-handed get syntax. So I'm going to say public game object. I'm just going to say splatter prefab with a capital S. And then I'm just going to use the arrow syntax to return my splatter prefab. Now you could of course just change this to public, but we're following good coding principles and we don't want to do anything like that. We want to make sure that we can only modify what this actual splatter prefab is in our serialized field or directly in this class itself. So let's go ahead and duplicate that line and do the same for our death VFX, and I'll just call it my death VFX with a capital D. Next up, let's head over to our death splatter handler and refactor some of this code. Now we haven't actually let this script compile yet since we created it directly in VS Code. So I'm going to head back into Unity, let it compile, and then just open back up VS Code to make sure that both the compilers are getting detected correctly and IntelliSense is working as well. So I'll go ahead and open that back up in VS Code, head back into my death handler class specifically, and we can continue. So now with these compilation errors that we're getting, we need to refactor what isn't working plus a little bit more. So instead of actually just calling on death directly, I'm going to hold Alt and change all four of these lines at the same time. I need to go into my health class, dot on death, now because it's a static event attached to the class directly, which is why it's very important that we pass through that specific instance of that health class. So with these compilation errors, it's telling us that we're getting these compilation errors because these methods aren't passing through the data that we pass through as the action. So we have a bit of a contract saying, hey, if you're going to implement and subscribe to this arm death event, you need to pass through this health class as a parameter. So let's go ahead and do it first for the spawn death splatter prefab, and then I'll let you do the second one as a challenge. So I'm actually just going to comment this one out entirely to make sure we're not getting any compilation errors. And then we'll go ahead and do the first one, spawn death splatter prefab first. So we need to pass through that health class, and then I'm just going to call it sender. I feel like is relatively common naming convention that I've seen. So instead of just grabbing the splatter prefab and instantiating that, we want to instantiate the sender splatter prefab that we made as that public getter. Instead of just spawning it at the transform.position of this newly created death splatter handler class, we need to just say sender.transform.position. Going from top to bottom, what else isn't going to work? Well, we don't want to get the color changer of this class. We want to get a sender.getComponent color changer. That looks good. That looks good. The only additional thing I notice I'm missing that I'd like to do is parent all of our splatter prefabs to the same game object in our hierarchy to make sure that they stack from top to bottom, and we can sort them properly to make sure that the last one that spawned always appears on top. So I'm going to say the new splatter prefab, and I'm going to set its transform.setParent equal to this dot transform. And we'll make sure that we set up this class as a separate game object in the hierarchy. Nice. Let's go try that out back in Unity. Let's go ahead and create that in the hierarchy. Let's just call it the death splatter handler, the same as the class to make sure that we can always find it. Let's attach the class we just created. And then on this death splatter handler game object, we can add a component as a sorting group. We can change the sorting layer to VFX and then just change the order and layer to 1, just like we had it for our splatter game objects. But what this is going to allow us to do is it's going to sort this entire game object, and the last most child, or the one that is last most spawned, is going to appear on top of all of the others always. Nice. Let's go ahead and try that out. Yes, my favorite part. Let's kill some enemies. So we've got a green, we've got another green, and then let's go ahead and try to kill this blue over here. Ah, there we go. There's one. And as you can see, this blue is always going to appear on top. You can play around with it as much as you'd like to make sure that it's working for you correctly, but yes, that is already feeling a lot better. And for this lecture's challenge, refactor our spawn death VFX method to work properly as it did before in our new death splatter handler class, passing through our health sender as data in our action event. Go ahead and try that on your own, give it your best effort, and I'll see you back here in a few moments. Welcome back. Let's open back up our death splatter handler class and let's go ahead and finish that off. So I will uncomment this, uncomment that, uncomment this entire method, and we can follow some of this same logic that we did above. So I'm going to pass through my sender, and I'm going to say sender.deathVFX prefab is what we'd want to instantiate, and I'm going to spawn it at sender.transform.position. I'm going to get the color changer of the sender, and it's not as important, but I'll just set the parent just like we did above for our splatter prefab, but instead of our splatter prefab, I'd like to do it for our death VFX. I say not as important because they're going to automatically get destroyed, but I think we're all set to go. Let's see, top to bottom, I think everything looks good. Let's go try that out back in Unity. Alrighty, 1, 2, 3, nice. We got the death splatter. We didn't kill it next to the tile map, but there we go. I think everything works nicely, and you know what? I think that's a really nice refactor, not only to clean up our code architecture, but now we also have everything spawning on top of each other to make sure that splatter color is always being instantiated correctly and appearing on top. Well done on this lecture. When you're ready to move forward, I'll see you on the next one.